Hello friends, today we are going to study about the molecular orbital structure of the benzene. As you have seen in my last lecture, how the structure of benzene was derived using the resonance theory. But the structure of benzene can be best explained using the molecular orbital theory. This theory was given by Linus Pauling in 1930. According to the resonance theory, the structure of benzene can be represented like this. So this is called the resonance hybrid or the actual structure of the benzene. And these two structures are called the hypothetical structure or the contributing structures. Since the benzene molecule is composed of 6 carbon, the benzene molecule is composed of 6 carbon and each carbon there are 1 hydrogen attached. So carbon is bonded to 3 sigma bond. If we see, each carbon is bonded to 3 sigma bond. These are the sigma bond. Benzene ring also have pi molecular orbital cloud. This is the pi cloud. This is the sigma bond. And this is the pi molecular orbital cloud. So in molecular orbital structure of the benzene, we have to discuss about mainly the two things. First is how the sigma bond form, sigma bond formation, and the next one is pi bond formation. We will go to the sigma bond formation. How the sigma bond is formed in the benzene or benzene molecule. The configuration of carbon is 1s2, 2s2, 2px1, 2py1. So in the ground state, these are the orbitals. It is 2s orbital, 2px orbital, 2py and 2p Z. So in 2s orbital there are 2 electrons, in px 1 electron, py 1 electrons. As we have seen in the benzene, carbon is bonded to 3 sigma bond, but here are only the 2 electrons. Here are only the 2 electrons, unshared pair of electrons. So carbon requires 1 more electron to form a sigma bond. So 1 electron get excited from this to this. So 1 electron get excited from 2s orbital to 2pz orbital because the energy gap between the 2s orbital and 2pz orbital is very low. So electron get easily excited from 2s orbital to 2pz orbital. So this is 2s orbital, it is 2px, it is 2py and it is 2pz. Now each orbital contains 1 electron. So now the carbon has 4 electrons, unshared pair of electrons to form a bond. But sigma bond is but the formation of sigma bond require only the 3 electrons because carbon bond 3 sigma bond. So sigma bond is formed by these 3 orbitals. 1 electron from s orbital and 2 electrons, 1 each from px orbital and 1 from py orbital, that is sp2. So carbon, the orbital of carbon is sp2 orbital, sp2 hybrid orbital participate in the bond formation, and it is the pz unpaired pz orbital. It is an unhybridized pz orbital that participate in pi bond formation, and this sp2 hybridized orbital participate in sigma bond formation. Now we can see this. Each carbon is sp2 orbital. It is an sp2 orbital. And each carbon is also attached to the s orbital of hydrogen. So sigma bond is formed between the carbon and hydrogen due to the, this is the sigma bond, due to the overlapping of s orbital of hydrogen and sp2 orbital of the carbon. And one sigma bond is formed between the carbon-carbon due to the overlapping of sp2 orbital of one carbon and sp2 orbital of another carbon. These are the sigma bond. All these are the sigma bond. So now you have studied how the sigma bond is formed between the carbon-carbon and carbon-hydrogen. Since sigma bond is formed by the overlapping of the planar sp2 orbital of the carbon and all the carbon and hydrogen lie on the same plane, that's why sigma bond is lie on the plane of the ring. So benzene molecule is a flat. Benzene is a flat molecule with all carbon and hydrogen lie on the same plane. I can also represent the benzene structure like this. Here the carbon-hydrogen bond length is 1.10 angstrom and carbon-carbon bond length is 1.39 angstrom and each angle is 120 degree because it is a planar molecule. So it is all about how the sigma bond is formed. Now goes to the pi bond formation. As you have seen here, these one electron from s orbital and one electron from px orbital and py orbital participate in the sigma bond formation, but this unhybridized pz orbital also have unshared pair of electron that lies perpendicular to the plane of the ring like this. If it is a benzene molecule, each carbon, if these are the carbon, so these carbon also have unhybridized pz orbital which lies perpendicular to the plane of the ring, and these pz, each pz orbital contain one unshared pair of electron. I can also show you the unhybridized pz orbital through this model. If it is a planar benzene molecule, it contains each carbon, these are the carbon at each corner, and each carbon contain unhybridized pz orbital that lies perpendicular to the plane of the ring. You can see easily these pz orbital are perpendicular to the plane of the ring. One pz orbital lies one half above the plane and one half lies below the plane of the ring, and these pz orbital contain one electron each. So overlapping of these pz orbital leads to the pi electron cloud. This is the pi electron cloud. This is pi electron cloud or called pi molecular orbital cloud. can be like this. Overlapping can be like this. If this is the benzene nucleus, overlapping can be like this. So it is pi molecular cloud and it is delocalized. Most important is it is delocalized. It is delocalized. This delocalized pi electron cloud leads to the stronger pi bond, which gives stability to the benzene molecule. So the delocalized pi electron cloud leads to the makes the pi bond more stronger, which gives stability to the benzene molecule. That's why it is the only one reason, that's why benzene molecule undergoes substitution rather than addition reaction. So it is all about the molecular orbital of the structure of the benzene. Thank you so much.